Okay, so as Rob said, thank you for the intro. We're starting the second workshop, and this time it's all about visualization using Mercury. So just a very quick thing, as I say, the overall aims of these workshops is for UK undergrads, sort of support and enhance research projects, because we've had time sort of during these COVID times, we've had difficulty getting into labs and running the thing. So that's the main thing. And hopefully the workshop today on Mercury will provide you with some useful information. So last week we did an OLEX 2 workshop. This week we're doing Mercury, and next week we're going to do Conquest. So we've got the same format of things. So there's introductory talk, sort of just a few slides. Then most of the time we spent doing the demo, Q&A session at the end, and we'll also give you some pointers to further data and resources you can watch. And if you do get stuck in the demo, we are recording it, so you can watch it sort of again, and also hopefully might be able to answer your problems in the QA at the end. So today we're using Mercury, so we've got some learning outcomes. Hopefully we'll be able to show you how to use the Mercury interface, learn how to use the basic options so you can easily visualize sort of small molecule crystal structures. So we are talking about sort of chemical crystal structures, although they can be quite large. Visualize how you can do packing, so it's not just one single molecule, it's lots together and how they interact. How you can get extra information just from the structure. So, okay, you're able to see the structure, but how they interact with their neighbours is often vital to understanding properly the physical properties of your chemicals. Okay. And finally, sort of creating hopefully some nice high quality images so you can put them into presentations, reports, sort of transfer things, any sort of thing that you can view things. So what we should have, we have given you there are 3 files we're going to be using today, which is sort of 3 very simple CIF files that are, when you sort of look at them, we'll go through them. So it's simple organic, sort of something that relates to a MOF, so a metal organic framework, and a simple coordination complex. And hopefully so that even if you're sort of studying one area of chemistry, there'll be one of the structures that will hopefully relate to you. So we can't do all structures, but hopefully there'll be something there. If you haven't had things, as I say, the files themselves are tiny, they're only a few K each, so they can be sort of copied and downloaded. Mercury itself is a bit larger, and if you haven't got that yet, I would just watch the presentation and do the download afterwards. Something else we handed out was there's a handout, which you can all sort of follow along to as well. This one, covers the same notes as I'll be talking throughout the demonstration, but there are sort of some of the pictures will be slightly different structures, and some of the ordering might be different. It's sort of simply the best way of mentioning how you do things, but sometimes sort of the order can be slightly different. So just be warned that sort of just check and things. So it might be sometimes you might want to take notes and things, but hopefully the ordering should be pretty similar. And that's the introduction. Here is Mercury. And on the first thing we have sort of, as I say, it's standard Windows sort of setup. We've got a whole load of sort of menus at the top, sort of tabs. We've got a whole load of toolbars. And at the moment, we don't have any structures. So just one thing with Mercury, as I say, it is a visualization program. So it can be for visualizing your own crystal structures if you've got them, but it also can be very simply used sort of for visualizing structures you might be sort of studying, sort of people who have already done the structure. Also, if you've sort of researching so on, so you can just look at any structure you like. So as long as you can get the CIF file, and you've got coordinates, you can view the structure and start doing some of these interactions with it. So don't worry, we've got things. So as I say, there are a lot of options, but for today, I'm only worrying about a few of them. So as I say, there's a whole load of tabs at the top, but I'm only worried about the ones on the left-hand side. So File, Edit, Selection, Display, and Calculate. And to be fair, most of the time I will be spent talking about sort of Display and Calculate and the odd thing for the others. Fortunately, we start with File because I actually haven't got any files at the moment, so I have to open some files. Open. Go into the folder. And one of the things you can do is I've got the 3 CIFs. And if I select them all at the same time, I can open them. One will go on the screen and the other 2 will appear in my structures listed on the right-hand side. As I say, if I want to go between them, I actually want to click sort of the second thing, so it's not the CIF file, it's the name underneath. So if this is the first structure, that'll be the second, that'll be the third, and so on. And you can see the structures have changed. We'll go back to the first one. So you can have a list of structures on the right hand side. Sometimes it might contain the whole database, but for now, as I say, we've just got the 3 I want. Right, so we have our structure. Good. Now, almost everything in Mercury is controlled by the mouse. So what I'm doing at the moment, left mouse button, held down in space, and I rotate the structure. Nice and simple. If I actually use the middle mouse button in space, I will translate the structure. The right mouse held down, if I go down, it zooms out, go up, it zooms in. Nice and simple so far. Move back to center. You then have keys with the keyboard, so if I do the shift key and the left mouse in space, rotates about a central atom, sort of somewhere at the pivot position. And if I do control key and left, it mimics exactly the same as the middle mouse, where I can translate sort of around the structure. So generally, when you sort of run a structure, quite a lot of the time, sort of it should be zoomed in the center of the molecule, sort of center of the screen. Sometimes when you add features, they might add up on one side or the other, and it is a very simple case to move it around and so on. So there shouldn't be any problems sort of moving them out. That was all, as I say, mouse button clicks in space and held down. If I just sort of left click quickly and release, nothing happens. If I right click quickly, I get a menu. We'll discuss that in a little while. If you do it on an atom, left click, you then get it highlighted. So we now have sort of what is actually a yellow mesh. It looks like a yellow sphere at the moment, but trust me, it's a mesh. And when we do it on some other structures later, you'll see the mesh appear. And I can do it on another one. If I click again, it disappears, or I can click on a whole load of them. So simply how you select them, select individual atoms, and so on. If you right click, you get a different menu, which will describe things. So that's your basic mouse controls on the screen. What we're going to do now is sort of start using a few things. So we've done the right mouse button, that's fine. Go to menus. So we have on the screen a whole load of toolbars as well. So we've got the tabs at the top, so I can keep going through. You also have a whole load of toolbars. So I've already used this structural navigator on the right hand side, sort of to load up my structures. I will spend a lot of time actually using display options, click on the things down here. And you have a whole series of simple tabs up here. Probably the most important one, and the one I will keep, you should always look at, is actually this picking mode. I will go through a whole load of things afterwards, sort of go through what most of these actually mean. But one of the most important things is every so often, sort of when you run through certain commands, various things change in this picking mode. And pick atoms is the only way, sort of where you can actually sort of do the on-off selection. So sometimes this will change to other features and you won't be able to do what you want. So if something goes wrong and you're wondering why, it's almost always due to this picking mode is in the wrong actual mode and action. So it's something you can always look at. So we go through most of these. So if you haven't got a toolbar, we find them in the display. So there's a listing of all the toolbars. Whether we need all of them, if you're interested in some of the extra things, I believe these are the default options. So things, but as I say, the vital ones, if you don't have the picking toolbar, sometimes things can go horribly wrong. And the same with the display options thing down here. Sort of, you have a lot of options which are very simple to reset thing. And probably one of the other ones down the bottom is this reset. If everything's gone wrong, you can click this and it will reset back to the starting position you started with, which if you've got problems, that can always be a help. So that is I've sort of talked about a lot of the toolbar options and everything else, but we haven't actually done anything on investigating the structure. So we have started with sort of this molecule down here. Zoom out a bit so it's a bit larger. Hopefully you can see it. Got nothing, what it is. And one of the sort of the other toolbar thing is this style. So we have got wireframe, and wireframe is a very good sort of basic thing of being able to see, as I say, your basic outline of the structure in a wireframe. It allows free, easy movement of your molecule, and often when things get more complex, sort of often using the wireframe, you might be able to see things that when you sort of go for the later styles, which I'm about to show you, sort of can be a bit more complex. However, for actual diagrams, often it's a bit plain and sort of difficult. So as I say, most of it's the background. So therefore, one of the things I normally use when looking through a structure is actually cap sticks. So this one just increases the size of each of those connectivities. And generally you can still get the colouring of the elements. Again, if you actually want to, you can change the colours as well. We'll go into that. Again, I find this as a useful compromise between the wireframe being sort of too little information and some of the other ones having sort of too much space. We can go down, we can do ball and stick, and this is often, if you think about it, much more like sort of say what you might have been seeing in OLED and quite a lot of the other programs where you just have sort of your atom as a ball and sort of the bottoms of connectivity. Again, it's a little more complex, it's still moving around. But if we want to say what's probably actually happening, then the fourth option is space fill. You now don't actually see the bonds, but you now got the van der Waals radius, and you can see how closely connected things are and whether sort of there are possibly interactions or whether you've got bonding or not. So with how the molecule actually fills sort of the volume, and then we can possibly see what's sort of whether there are things connected. But I have to say space fill is a lot more computational. At this size, it's not a problem. Once you have huge molecules, sometimes you'll have issues where you'll watch this thing and it will move and it'll just go from one position and it'll go to another position. And even on your screens, I think I'm having issues where it's jumping and things. So you can see that even just this simple bandwidth slows things down. So we'll go back to capsticks, and then you can see it moving all the time. So it's one of these where sometimes you might pick the style you want for your diagram, but before that, sort of you spend your time preparing the structure in one of the simpler forms and then going to it. So that's capsticks. So one of the other things you'll notice, this molecule, if you don't actually know, is paracetamol, and it has an aromatic ring and a carbonyl group. Now, on my structure, you'll see that we've only got sort of single bonds. And that is sort of deliberate on my part and often deliberate on the crystal structure. We are showing connectivity, we are not showing bond order. If we want to, we can show bond order, or if it's important to you, we can do it. And so there is an option in the edit menu. So auto edit structure, and we can do yes bond type, standard conventions for aromatic rings, delocalized bonds. One thing we don't want to do is make sure this add missing hydrogen atoms is ticked off. Simply, okay, it might be sometimes sort of there can be issues about whether you're meant to have the hydrogen, so we don't want to change the structure. All we want to do is look at the bonding, sort of whether you have aromatic rings. So click apply, gives me some options, and click accept. Apply, oops, and close. Oops, not. Yeah, I forgot to change something. So what should have happened is in the display styles, these two options should have been. That's better. Sorry, my apologies for that. So we now have the double bond and the aromatic ring. As a crystallographer, I prefer actually just seeing bond connectivity. So in fact, as I say, if I want to get rid of them, I go into styles, and there's two options here, which is display bond types and style display aromatic rings. And so, and for if you want them in, as I say, we can now go back in and I can put them back in, just tick them, and if I don't, we take them back off. But we'll see what happens later in the structure when we do the diagrams, whether you need them or not. As I say, some people like them. I prefer just to look at the connected and just see what is connected to each other. So, okay, so as I say, haven't done too much on the molecule, still rotating it. One thing we're doing, I'm going to go for the picking mode. So I said we've been doing pick atoms. Top one, as I say, click on thing, comes off. In fact, if I just change to ball and stick, and on pick atoms, you'll see you now have the mesh. And if I do it on the space fill, you'll be able to see a much larger mesh as well. But we'll go back to capsticks. So if you want to do lots of atoms, there's a lasso atoms. And this, you can see the icon has changed to a lasso, and then it's hold the mouse button down and then lasso the atoms you want. And all of them will be selected. If you keep the lasso, then you can do another one, and it will just lasso the new ones and so on. And you can keep going through. If you want to actually undo it, then the two options, we can either go back to the pick atoms or we can change the things up here. So this is a pick atoms and that's the lasso as well. So you've got two options of how to do it. If you don't want the selections you actually want, the easiest thing is click in selections and actually do deselect all. And again, just going for this menu, you've got a few options. So you can select all of them, you can select molecules, and so on, and there's some select options. So quite often, as I say, you might not want to do the hydrogens, or you might just want to look at the hydrogens, so we can go through. So if I do non-hydrogens, you see, leave the hydrogens, and we can invert and so on. So there's a whole load of ways you can decide what you want to select. That's fine, but for the moment, I'm going to do deselect all. Now, going through the list, I'll leave expand contacts for a little while. We then have labels. So the easiest thing, we have toggle labels, and if I click on an atom, it will come up with a label. If I click on another one, it'll come up with a label. Doing it one at a time probably isn't that advantageous. So again, if we go down to display options, we can do label atoms, and you can see them. Now, the atom labels, I think you'll probably say look a little small on the screen. In fact, they look very small. So what you can do is display labels, and we've got label color and label size. At the moment, I'm just going to change the size. Instead of being 10, let's go for 20, and you can now hopefully be able to actually read the labels. Generally, most people don't want to label all the structure. So again, we have another tab here, show label, and it's saying for all atoms. So what I'm actually just going to do is go for non-carbon hydrogen. So we've just got our heteroatoms, the nitrogen, the oxygen, and the oxygen. Go back to the picking mode. We have move labels. Sort of quite simply, that N1 isn't probably been that helpful over the nitrogen. So if I actually click left mouse button over the name and then move it, we can do the same for the oxygen over here. So it's left mouse button, hold down, and we move them away. And once they've moved, when we rotate, they will stay in that position to the atom. Of course, if we get it wrong, sometimes you might need to move it again. But hopefully, it's now a nicer shade of where they are in the structure position. And again, you can do it. Some people want to have everything labelled. Some people don't want to have sort of atoms labelled at all. But you can decide which ones you actually want. Now, if you decide you actually, okay, I've picked these, but I actually don't want to have, I don't know, let's have this O1. So if you right click on it, if we click on the atom it's next to, do labels, and we can do hide label, and we just lose the label. On this thing, this tab up here overrides sort of what's happening. So when you do label atoms, sort of it will start and they'll appear again. So when you click this one, it's only which ones you actually want to mention. That's fine. So we've got atoms labeled. I think we've moved. Now measure distances. We already know sort of probably what the distances of the bonds are, but if I just click on two atoms, you can get a bond length. The one thing is, we don't have to measure the distance of where we have a bond, so I can actually just be between the two oxygens, and it could be a bond length, and we can do as many as we like. Again, it's not a problem. We can move the things, and we can change and decide. Okay, I like the bond length, but I don't actually like the measurement. So I can right-click and click delete measurement and it removes it. Or I can do, if I want to do all of them, I can click clear measurements and remove them all. Of course, we've got distances. We can also do angles. So let's do that atom. There we go. Doesn't matter, but you can get angles if you want to actually get a sensible angle. We can put them in and so on. And we can do torsion angles as well if we want. So we can measure distance. And as I say, we're not doing sort of just simple bond distances. We can do any position, any two atoms, well, any two atoms for a distance, any three atoms for an angle, and any four atoms for a torsion, as long as you do them in a particular order. I'm not happy with that measurement, so we'll do clear measurement. So we've got the structure, we're looking at it. So one other thing we can do, I've changed the size of the labels. It's also not difficult to change the color as well. So we can do labels, we can change label color. And although it's on black at the moment, so let's do yellow. Hopefully you can see they've changed. As I say, sometimes you have to be a little careful where you're clicking. So if you click directly on the label, sometimes it might come up with the right thing. If you do it over the atom, it'll come up with a different menu. Although in this case, labels, you still get the label color and size. And in fact, I'm just going to go back to white for the moment. We'll leave it for timing. Yes. But if for some reason you wanted to highlight, say, this carbon as something special, got it highlighted, so left mouse. Actually, we want to make sure we want to pick atoms. Then what we could do, we've got this color, so we could actually just change it. Okay, probably red isn't the best color because we've already got, so that would make it similar to oxygen's. Let's go for purple. At the moment, there's nothing else. So if you want to sort of specify an atom or in fact the whole molecule, we can always change the color. And if you're unhappy, we can always go back. So one of the other things is we've got color by element up here, so it's yet another tab, and it's always saying, and that will reset all the atoms to the elements they were colors based on the elements rather than anything we changed. So you can sort of go around and change colors to anything you want, just so it stands out. Finally, just before we do anything else, so as I say, I've been doing everything on this black background, which for this presentation is absolutely fine on computer screens. But if you want to present it in a report, in a thesis where you're going to have to print it out, sort of black is still horrible for printing. So we have a few options to get to the same thing. So again, go into space and click, and we have draw backdrop and display options. And if I click on display options, actually I will do it from here as well. So in display, we can also do display options, and it come up with exactly the same menu. At the moment, all I'm worried about is background, and this is what we do. At the moment, it says single color, and I want to have it to white, and that's fine. And we now have it white. So if I now right click on space, and you see the draw backdrop is ticked, if I untick it, it will go back to black. But having changed it to the white one, just something for sort of, this is for if you're doing reports presentation. If you've got to do a presentation where you're sort of visually showing it, so you're doing a PowerPoint and something else, sometime, and you want to really highlight something, I have to say sometimes the gradient options, although it might see things, do one, for some reason, you can see, is that often just by doing the graded shading, you can play around with them, I think, but it often seems to make the molecule stand out much more visually than just having a plain background. So it's a bit more computational thing, and as I say, it sometimes slows what my display is, so I don't want to have it all the time. I'll go back to single color, but as I say, sometimes it might be nice sort of just sort of having that shaded background sort of on a picture just to highlight the structure you want. Okay, so on single color and close. But what, as I say, since I'm using for the presentation white, and a lot of white doesn't look good, and it's slightly high hydrogen, so I'm going to do draw backdrop, and we're going to go back to the black. So I've been doing a lot on this structure, we want to be I've been talking about that you can pack the structure and things. So if we go for the packing, and there's lots of ways of doing packing. So the easiest way is just to tick this box down here, packing, and we get a structure. So we get multiple atoms. Zoom here. So we get the unit cell. We get 4 in this case molecules. And we can start to see how the molecules could actually pack. And if we actually change this time to the space fill, you can actually start to see how the molecules will interact with each other, where there's close contacts, where there's things, and why there's, although you see space between molecules when they're packed, if we actually put the space fill up, you can see there actually isn't a gap between them. It's just where the centers of the atoms are and how we want to view them. As I say, this packing is by far the simplest. If I want to do instead, we can do calculate and packing slicing. We have a whole menu here. This pack basically does the same thing, and actually, just to let you know, this packing tick here basically does exactly as what's on this packing thing. So if I change the values here, so I change the simplest thing, change it 2 by 2 by 2. Go for 2 by 2 by 2. It will do the packing for me as a 2 by 2 by 2. You'll quite think very quickly that this is now getting to be quite a complex structure. So I will quickly reset it back to 1 to 1 to 1. I will do the reset and the packing so it's in the middle of the screen, which can be. Now you also see that we have the unit cell and they're labelled, so we can see the A-axis, B-axis, C-axis, and other things. Just to let you know, as I say, this is the the unit cell, the imaginary construct that allows you take this and translate it in every direction, and you build up the crystal you can see. And as you can see, actually, every single one of these molecules doesn't lie within the unit cell; it goes in and out. And this is actually pretty common. So most of the time, you'll actually have your molecules going in and out of a unit cell. So we have various options, and what we actually want to do is click the one, and this is actually what the unit cell really looks like when you pack it, and you see we haven't got a full molecule, but if we connect up and we do it for the centroids, we'd say where they are, and if we do that one, this is everything that's actually has even one atom inside the unit cell. So we've got a whole load, but generally, as I say, you want to have the same number, so you have the Z prime correct and where the centroids are. We can minimize and instead of doing whole cells, we can do smaller amounts. Oops. So we can do it +1 at a time, and you see when it increases, and we can play around with the cell packing. And that's, as I say, at the basic, that is how you can do the looking at packing, just on the whole scale and so on. However, quite often what you actually want is you start with the molecule and you want to know, right, so what is, say, nearest to this oxygen? And this is where we have our two things, the short contacts and the hydrogen bonds. So short contacts is everything that's within the van der Waals radius of each of those atoms. And we now suddenly have a whole load on the screen of dots, and each one is connected to has dotted line connected to your molecule. So some of them, and all we've got are the labelled ones because I've only got the atoms that are labelled as oxygen, nitrogen, and so on. So, okay, so we have hydrogen here and carbon. So let's see what happens. And when you click on an atom, it just builds up, puts in the new molecule there, and you also get a whole load of new short contacts on everything that's near to that atom molecule. And we can go through everything at the stage. I'll go through short contacts a bit more in one of the other structures, but we also have hydrogen bonds. Go for reset, and this molecule has two lots of hydrogen bonding. So we've got the nitrogen down here and the oxygen here. So we can click, and you say you have a lot less molecules, a lot less of these dots. But again, we can click. Okay. And each time you grow, you'll get a new thing. So you can see whether it's say an internal hydrogen bond just between two molecules, that's say, so you have a dimer, or on this case, we're starting to get an entire network. So each time you get more and more molecules, and they'll continue. I can zoom in. So That's fine. So I have been talking a lot with this molecule, which if you're fine for an organic chemist, that might be happy. But as I say, we have other examples here. So I'll do the reset, click OK on that, and we'll go for the next molecule. So actually what I am going to do now is go to SAHYK, so SAHYK, and this is a moth. Now what I'm going to do is, as I say, I've got non-carbon hydrogen things and I've got a whole load of zinc, oxygen, but actually for the moment I'm going to get rid of all the labels completely. Now, as I say, this is a moth. So I can do everything we've done before. So I've got cap sticks, I can do space fill, I can do ball and stick. I'm actually going to go for wireframe because my next thing I'm going to do is packing. And now have this thing, it packs inside the unit cell. There's now a lot more atoms inside the unit cell. And if I go for a sort of ball and stick representation and start trying to think, I can see that actually it's starting to slow down my rotation, and some of yours might be as well, so you might not get full rotation. So I'm going to go back to the wireframe. Again, I will take out the packing and do short contacts. And you see we've got most of the short contacts in this case are actually sort of molecular ones that when I click it, sort of you actually just grow the molecule a bit more. So this, as I say, is a 3D network, so there's never actually a sort of an end to the structure. So whatever happens, you've actually got more of the structure wherever you go. And I can think now, sort of, if you want, so let's do what I'm actually going to do, get rid of the short contacts, reset. So we're going to go for the packing again. And what I want to do, I'm just going to go for the ball and stick. So some of the other things we can do, as I say, we can do measure distances. So let's go from, see how large the distance is. So we can go across that void in the middle, sort of 22 angstroms. So how far is it sort of in on a sort of a side, say 12, and we can do diagonals and so on. So again, sort of with the large structure, you can still do as long as you want on the distances and so on. Now, I will just clear these measurements and just show you what happens now with the larger labels. It's probably a bit too complex, so actually, if I want to have labels on this structure, I am happy to have possibly things. Let's just have the metal ions, and I'm actually going to have a smaller size. So click labels, label size. Let's go back down to 12. Might seem a little small, but as I say, you might just about be able to have labels, and that should be okay. So we got 2. Okay, or not. But what we want to do, what I've been saying is that it is possible, sort of, to say we've got measuring distances, but one of the next things we can get nice pictures. So, as I say, one of the reasons for doing this is you've done your packing, you've got it in the way you want, so you actually want to get a nice diagram out. So, yeah, might be okay. Have it around a little bit. Let's have it there. Zoom out a little. So if I'm going to be having a diagram, I probably want to have a backdrop, so I'll have it as white. Yeah, doesn't look too bad. As I say, you can do what you like with the diagrams. It's your choice, but to actually show you how to actually make a diagram, all we need to do is use the file menu, and we can do save as. And we have a whole load of drawing package sort of things, so you can have bitmaps, JPEGs, PNGs, POV-RAYs, and TIFFs. So there is a whole series of how you can do. So if you know about POV-RAY, you can do very intrinsic sort of intricate diagrams using that and get a whole load of things. But for simple cases, personally, I can't get away with just using PNG, and we can have it with transparent background, so you can overlay, put it overlaid to something, so you don't have to have the white. And my standard option is always do something based on the current window size. So you can always sort of cut and crop sort of an image later if you've got white space on either side. If you start playing around with the size and try and do it 1000 by sometimes you can get stretching and it can all go wrong. So personally, I often just do it as this, window size, do OK, and it will save and produce a nice image. And again, you can decide what you want to do with it and view them and so on. But as I say, it's your choice on how you want to think, but that's how you can do a saved image. As I say, if you want to do proper images, there's a whole load of intricate things there, but that's simple for that. And personally, sort of it depends on what type of image you want. So the multiplication times 2 is perfectly sufficient for all structures I know about, but sort of publications. But if you want something a lot more complex in things, you can go for higher resolution, but the images do get very large. So anyway, so that's with a moth, and you can say we can do a whole lot of things. We'll go back and do reset, so we're back to the start. So one other thing I should warn you about with this moth is this is the thing. On here, there's actually an asymmetric unit, and this is actually what sort of you would do if you're solving the crystal structure. So there's only a few atoms. So if you do have this clicked, sometimes you might if you have asymmetric unit thing, you might not see the whole molecule, or you might see more. It's just knowing what's in sort of the asymmetric unit of the molecule. But for moths, that's quite common. But what it does is it grows as fragments, so you can actually, so when you view it visually, you start by seeing the basic fragments. So you expect so a whole molecule of the system, and then you can grow it later. So we've done 2 my molecules, so let's get off to the third one. We haven't got a few minutes. Good. Okay, so I've left clicked and we're now on my third molecule. So this is just a coordination complex. We've got sort of nitrogens coordinating 2. Let's see, what do we have? So on metal atoms, so it's a ruthenium, and we've got some chlorines and so on. So let's go for capsicles again. So we've got the same sort of standards. I can do my distances, but on this case, what's sort of the last thing I sort to show you is sort of centroids and planes. So on the display option, so in the calculate, we have 2 options at the top. So the first one is centroids. So always try and move the window to the right hand side, and we want to have a centroid. So there are ways of things. We've got picked atom, picked molecule, and ring. I will do picked atom, and if I notice that my picking mode is still in measure distance, so if I did that, I would click 2 atoms and it would give me a distance. I want to be in pick atoms. So we've got a ring here. So if I click on the 6 atoms. So as I say, you only actually need 3 atoms to define a plane, which will then define a centroid with the 3 atoms between it. But in here, we've got a pyridine ring, so we can do. I'm going to tick off the label so it's not C. So we just stick and we get a centroid in the middle. If I actually want to have the label there, I can click on the edit and I can click it and it appears. But as I say, the centroid might be sometimes labels, and if I want to, I can change it, but for now, I'm just going to close it. So we've got centroid, so let's see. Let's do one more centroid. So I'm going to do another one. I'm going to change the color, yellow. This time I'm going to do ring, and I've got a benzene ring here. So if I click on an atom, it selects all 6 atoms. Again, I'm not going to have it labeled. I'm going to ring. It should be fine. So let's see. Let's do some distances. So we've got a centroid, and they can be involved in distance, angles, and everything else. So I select ruthenium, select centroid, and I can do the one over to there. And of course, I can see quite happily how far they are apart from each other. So if you do want centroids and want to look at things and distances and so on, that might be the way to go. And I will clear the measurement. But sometimes you don't want a centroid, you actually want the plane. So this is a benzene ring. It's also a plane, or in theory, most of the time it would be a plane. So we can do calculate planes, get the window, new plane. Again, I've got the sort of basically similar options here. We've picked atoms, molecules, or things. We can select a whole load of things. I am going to tick off the label, but we'll start with this plane, this aromatic ring. So we can do ring, select an atom. I'm on measure distance, so I need to be on pick atoms. I'll click the ring. So it's very easy to change picking mode, which might go wrong, and we do OK. And now you have a plane, and it is defined. If I actually click on it and have the label, you can see it's actually mentioned where it is. Now, okay, I'm just going to do one more plane. Again, you know, I hope people aren't colorblind. We can do green. So we're going to have a ring. So you can have overlap sort of planes and centroids and things that can overlap. So what we want to do is sort of, you can also use the things to measure distances between the planes. So we've got measure distance. So we can go from this centroid to this plane. So if you need to click on the plane, just left click somewhere in the plane. You can see the 3.2. Yes. Now, if I try and do measure distance between the two planes, it will give me 0 because I can see that at some stage the planes will cross. Therefore, actually, the only thing I can do on these planes is measure the angle between them. So if I click on one plane and then click on the other plane, you can see, and we've got an angle of 16.86 degrees. So once you've got a plane and once you've got the thing, you can start doing measurements and sort of determining whether things are happening with, and you can see things like, okay, bending ring, so you can actually see that this nitrogen actually comes slightly out, so it's slightly distorted. You can start to see distortions of, say, this four-membered sort of thing, whether the ruthenium's up above or below, and so on. So there's a whole load of things you can do with centroids, planes, and so on. And as I say, and as you start to get more complicated structures, so if you might want to sort of save your work, because when you load up a SIF, so if you will just save the atomic coordinates, so you will just save where the atoms are and their elements, so you won't actually think. So if you do want to save a lot of information, so like this one thing, there's the option, and we need to do save type Mercury, and it saves it sort of the semi. And once you save it, that it might not have all the planes and everything absolutely perfect, but it will have things like, it will have your centroids in position, it will have the planes, it will know that you've defined them based on these atoms and these atoms. It might not remember your distances if you've removed them and so on, but it will have a lot of the information. It will remember your backgrounds, your colorings that you've had, so anything you've changed color and so on. So if you need that, as I say, it means you don't have to start again. So it's a very useful, as I say, way of saving your work if you're spending a lot of time trying to design and get a beautiful sort of structure for a picture. Yes. So, and I think that is about the end of my demonstration. So we can get things, I'm just closing these. So if we have sort of, let's say, these are sort of basic examples of what we want to do, but hopefully sort of the last picture in sort of in the handout is what is actually possible using Mercury to get sort of very complex pictures. And if you want to sort of, as I say, there's more stuff on the sort of websites as well. So CCDC have produced a lot of videos, tutorials, sort of demos that you can go through and pick on things. But I think that is it for my demonstration this afternoon.